All right, so today's lesson is going to be on inverse functions again. We're just going to uh, continue the discussion. We're going to mess around with inverse functions for the most part, but these three questions would be things that hopefully you could answer before doing this video, right? So arctangent of 1 would be asking where is the tangent of theta equal to 1? So we're looking for theta, right? And so tangent of theta would equal 1 when theta is pi over 4 and 5 pi over 4. But remember, there's a range to the arctangent from, whoops, wrong. Theta has to be from negative pi over 2 to pi over 2. So if you've got those down, then you kind of know how to answer this. So this would be pi over 4. If you don't have those ranges down, I would consider going back to your notes, looking at those, making sure you feel good about it all. Maybe do some of the homework and things like that. All right, so the inverse sine of 1/2 is where I'm going to start. That would be pi over 6. That would be the angle that would give me a sine of pi over, or sine of pi over 6 would be 1/2. And then we're going to do the cosine of pi over 6. And the answer to that would be rad 3 over 2. All right, so that's how I would do both of those. The next one, to solve the equation of the interval, and you're going to need a calculator for sure in this regard. So you're going to add 4. So 3 cosine of x equals 1. Then cosine of x equals 1/3. And then we're going to do the inverse cosine of 1/3. And so the calculator is only going to give you one answer. I'm going to snag that. I have a calculator open. I'm not going to, right? So 1/3, right? 1 divided by 3, enter, oops, control enter. So I've got 1.23 roughly, okay? So then, so x is roughly 1.23 radians. All right. Now that means that's only one answer, but if you remember, cosine is positive in not only the first quadrant, which is where 1.23 radians is, but cosine, so let me draw you a picture. So 1.23 radians would be like right here, but cosine would also be positive down here. So what we can do is we could say x would also equal, and if you're thinking about, okay, here's where 0 starts, you're going to go around to this thing, and this amount is 1.23. We could do 2 pi minus 1.23, and that would give us another answer. So let me just go to my calculator real quick. 2 pi minus 1.23, and I get 5.05. I'm going to use that, 5.05. And that would also be another answer. So those are going to be your two answers. Remember, the inverses can only give you one answer. And so if there's going to be two answers, you're going to have to go find the second answer from using kind of your knowledge of the quadrants and reference angles and subtracting, okay? All right, so what's today's lesson around? We're just gonna mess around with inverses a little bit. And so it shouldn't be too bad, but we're gonna try to do some without a calculator, all right? So this problem says evaluate the expression. So interesting. First off, right, the guy on the inside, this is going to produce an angle. And since it produces an angle, right, it would make sense because then on the outside, you have the secant, and then what do we normally do? We do the secant of theta, like we do the secant of an angle. So it makes sense that the inside produces an angle, so that then of that angle, I can do the secant over here. Okay, so this is gonna be done first, right? So this is number 1, and then after that, you'll be able to do the secant, which would be the second thing we do. So first off, the question would be is, if I don't get a calculator, how do I figure out the angle? Well, the thing is you don't. What you're going to do is you are going to say, okay, well, this tells me about an angle, so let's draw a triangle. So this is basically saying that the sine of some angle theta equals 4/5. So if I were to draw a triangle in the first quadrant, because it's positive, it would look like this. And here's theta. And then the sine is the opposite, 4, over the hypotenuse, 5. And this is a special triangle. And you can fill out the last side. That would be positive 3. And so now you have a triangle that's representing theta. And you actually don't need to know what theta is because you have this right triangle. Now that you have the right triangle of angle theta, you can come over to here to this guy and you can say, looking at the triangle, what is the secant of theta? And remember, secant is the reciprocal of cosine. So if the cosine would be 3 over 5, then the secant of theta would equal 5 over 3. So this whole thing in the end, the secant of the arcsine of 4/5 is just 5 over 3. And so I'm sure there's lots of other ways that someone could come about doing this problem, but the best way I would say is to use your understanding of right triangles, right? So to just draw a right triangle that the inside part represents, and then once you have that right triangle, you could evaluate whatever it says on the outside, right? So let's try a couple and let's see how it goes. So it says the arctangent of negative 4/5. So remember, arctangent can only be in the first or fourth quadrant. So since it's negative, we'll put it in the fourth quadrant. So here's my triangle in the fourth quadrant. There's theta. And so negative 4/5, right? Opposite over adjacent. So the opposite would be negative, negative 4, and the adjacent would be 5. This is not a special triangle, though it may seem like it is, because the hypotenuse is not 5. So you're going to actually have to do work. So 5 squared is 25 plus negative 4 squared, which is 16. That equals 41. And that's going to be c squared. That equals 41, if my math is right. And that equals c squared. So square root of 41 is the hypotenuse. Okay. Now that you have a right triangle, we can say what's the cosecant. So that would be the reciprocal of sine. So opposite over hypotenuse is sine. So we'll do the hypotenuse over the opposite. So square root of 41 over negative 4. All right. If you want to pause the video now and try the second one, I would, just kind of on your own so that you can feel like you got an idea before it. But then if you don't want to pause it, then you can just watch me do it. But I'd encourage you to pause it and give it a shot on your own and then watch the answer, okay? All right, so cosine, inverse cosine of negative 5/13. Inverse cosine can only be in the first and second quadrants. So I'm gonna draw this in the second quadrant. And cosine is adjacent, negative 5, because it's quadrant 2, and hypotenuse, 13. This is also a special triangle, that's 12. And so now you're doing the sine of that triangle, so that would be 12 over 13. And it's done. There's your answer, okay? All right, so just messing around. There's a lot of variations to this. We could do a bunch. I think I have some saved up for later on in the unit, but for right now, we're just trying to get used to it. So hopefully this all kind of makes sense. But now let's just take like all the numbers away, right? Like let's just take all the numbers away. What would you do? Here's what's going to happen is you're not going to do anything different, okay? So what you're going to do is you're going to keep everything the same, the idea, right? The inside tells us about an angle, and then the outside right here is what we're trying to evaluate that angle for. So the inside, inverse cosine of x, we're going to use this, right? First thing, and we're going to draw a triangle based off of that. Okay, and then this guy over here on the outside is what we're going to do when we evaluate using the triangle that we draw. Okay, so hopefully that makes sense, same idea. So thinking of cosine, this is saying the cosine, inverse cosine, right? But now it's saying the cosine of some angle theta equals x. So if you think of it, this is x over 1. All right, so then your triangle in the first quadrant is all I'm going to do. Think of it in terms of the first quadrant. This is your adjacent and this is your hypotenuse. And so this would be 1 and this would be x, leaving you having to find, let's call this, we'll call it b. Oh no, look at that, it went away. We'll call that b. So a squared would be x squared plus b squared equals 1 squared. So we're going to actually solve for b so that we can have an expression for the opposite side. So I'll subtract x squared, so I'll have b squared equals 1 minus x squared, and I'll square root. And so I have b equals the square root of 1 minus x squared. And we're going to leave it like that. So that's what the opposite side is. Right here, this is the square root of 1 minus x squared. Now that you know all three sides, you can say what the tangent of theta is, right? We're supposed to do the tangent of theta. And so that would be the opposite. That's what we found. 1 minus x squared underneath the square root all over the adjacent, which is just x. And this would be your answer. So it's going to be the same problem, but just like no numbers or fewer numbers with some variables added in to kind of just up the algebraic content of the problem. Okay, so I got another one right here. If you want, if we were in class, I would have said with some people around you, find the sine, cosine, and tangent of theta. But obviously you're by yourself. So if you want to hit pause and get a neighbor or a friend, safe social distancing, type stuff. But if you want to hit pause and try to find the sine, cosine, and tangent of theta on your own, you can. But I'm going to kind of just walk through it here. So if I'm going to find the sine of theta or the cosine of theta, I'm going to need the hypotenuse of this triangle. And so the hypotenuse would be found by doing the Pythagorean theorem. We're going to do 5 squared, right, plus x minus 2 squared, and that equals c squared. Okay, so this is going to be 25 plus x squared minus 4x plus 4 equals c squared. So I've got x squared minus 4x plus 29. That equals c squared. We're going to square root. C equals the square root of x squared minus 4x plus 29. Okay? Minus 4x plus 29. Oops. And that would be your triangle. So now you can just do the sine, cosine, and tangent. This is the opposite over the hypotenuse. This is the adjacent over the hypotenuse. And this would be the opposite over the adjacent. And you can just kind of go from there. All right. So sine of theta equals the opposite. So 5 over the square root of x squared minus 4x plus 29. If we really wanted to, we could rationalize the denominator. I'll hold off. Cosine of theta would be x minus 2 over, right, the square root of x squared minus 4x plus 29. And then tangent of theta would be 5 over x minus 2. Okay. And then if you were asked to do the inverse, right, think about it. If you're asked to do the inverse, theta would equal, right, like somebody says, I don't know, you could say find theta. And for any of them, you could have just done the inverse, which would have been like the inverse sine of 5 over the square root of x squared minus 4x plus 29. Something along those lines. Could have been crazy. All right, but that's kind of the idea. Make sure that you have all three sides before you're doing any of these problems. And if you're missing a side, that probably means you're gonna have to do some algebra with Pythagorean theorem. All right, so if you're feeling good, you should be able to do this problem. If you're not feeling so good, then keep watching. But if you're feeling good, maybe hit pause and really see if you can work through it. And I think you'll be all right. Okay. So tangent of the inverse sine. So I'm going to use the inside to do, right, inverse sine, saying the sine of theta equals 2 over x plus 3 is what we're basically saying. So I'm going to draw a triangle. There's theta. Opposite is 2. Hypotenuse is x plus 3. And so we're looking for this guy, the adjacent side. So I'm going to have to find that. That's going to require some work. So a squared plus 2 squared equals x plus 3 squared. So a squared plus 4 equals x squared plus 6x plus 9. A squared equals x squared plus 6x plus 5. Sounds about right. And so then you square root that. Look at that, how convenient. That's factorable, but I don't think that's helpful. A equals the square root of x squared plus 6x plus 5, right? And so here we go. If we're going to do the tangent, that's going to be the opposite over the adjacent, which we just found. And so this whole thing is going to equal, right, tangent of the inverse sine of 2 over x plus 3 is going to equal 2 over the square root of x squared plus 6x plus 5. If somebody wants us to rationalize the denominator, we can, but let's be honest, the world's not going to explode, so I'm just going to leave it. And hopefully that's okay with everybody watching the video. But all right, hopefully that makes sense. Really using the insides to draw triangles to kind of be able to get it, because you really can't find theta since you don't know what x is, but you can draw a picture, and then after drawing the picture, you can use it to evaluate, okay? So I'll leave you to it. Those are two problems that you could do. You could just maybe talk it out to yourself, like what would you do in each problem? All right, so you got options. Some you can evaluate, some you might have to do some expressions, but that's kind of the idea. If you want to keep watching, I'll finish them. Otherwise, if you feel confident about how you would do it, maybe you put the video on ×2 and just watch me finish it out, or you just try them on your own and see if you get them right and skip to the end of the video. All right, so anyway, thanks for watching, and I'm going to finish up these problems. All right, so here we go. The inverse cosine is 0 at pi over 2. And then the inverse sine of 1/2 is at pi over 6. I'm going to add those together. What's that? Times 3 times 3. That's 4 6. So that would be 4 pi over 6, which is 2 pi over 3. So we're really just doing the cosine of 2 pi thirds. And the cosine of 2 pi thirds is going to be negative 1/2. Yay, that's the answer. Food for thought, just going to throw it out there. If you did hang on and watch the rest of this video, what would you say you would do? And I'm not going to answer it right now, but I'll answer it later in the unit. What would you say if it was like the inverse cosine of 3/5 plus the inverse, I don't know, let's say the inverse sine of negative 3/5, like this? What would you do in a problem like that? Whew, man, that's amazing. Definitely going to ask that by the end of the unit though, so get ready for it. All right, but let's go to the last one. Arctangent of negative x. So I'm going to go like this, right? This is tangent of theta would equal negative x over 1. So we're going to have like the opposite over the adjacent, okay? So let's throw this in the fourth quadrant. Okay, let's throw it in the fourth quadrant since it's negative theta. This would be 1, that's the adjacent side. This would be negative x. And now we have to find the missing side. So we're going to say that this is going to be negative x squared plus 1 squared equals c squared. So basically x squared plus 1 equals c squared, square root, c equals the square root of x squared plus 1. That's what you're putting here. And then to do the sine, we're just going to say the opposite, negative x over the square root of x squared plus 1. Okay, and that is your problem. I'm going to throw another one at you. Any idea what you would do if it was the sine of 2 times the arctangent of negative x? Oh, amazing. I hope I never asked this question because I think the work for it would be terrible. Maybe it wouldn't be, I don't know, but I don't want to do it. But for either this one or this one as we close this out, both of those, just food for thought. If you're thinking like, man, how would I do it? How would I do it? I'm just going to say one word and then I'm going to end the video. The one word is you should use formulas. But anyway, just going to throw that out there. All right. I hope you guys have a great day. Talk to you later.